Right now, a device smaller than your thumbnail is in a race to hold a satellite in the most hostile place it can fly. Almost nobody knows it exists. But the story starts not in a rocket lab. In 1914, a University of Minnesota chemistry lab, where John Zeleny watched charged liquid jets break into droplets, with no idea what he'd found. That phenomenon sat dormant for decades. Then in 1989, Nobel laureate John Fenn used the same effect at Yale to analyze proteins, a biolab tool with no connection to space. Yet, then a single question bent the trajectory of everything. At MIT in the early 2000s, Professor Manuel Martinez Sanchez asked, "What if you aim that ion beam at the vacuum of space?" Here's what makes this staggering. At VLEO altitudes below 250 kilometers, atmospheric drag is 100 to 1,000 times stronger than at conventional orbits around 550 kilometers. Without compensation, a satellite can fall from orbit in days or weeks. That's when Paulo Lozano, a graduate student from Mexico City, obsessed with elegance, spent years proving this could work. MIT's Space Propulsion Laboratory developed Ionic liquid electrospray, thruster technology that has since reached the leading edge of the field. Think of it like a candle flame flying a spaceship. Not the heat, the pressure. That whisper of force, in the frictionless efficiency of near space, could keep a small satellite station keeping at orbital velocity, if the thrust precision holds across a multi-year mission. In 2014, Lozano's former PhD student, Natalia Bailey, co-founded Accion Systems, betting a technology that had barely left the lab could become an industry. The manufacturing wall was the next challenge. ESA's GOCE satellite flew at 254 column for roughly 4 years, kept alive by ion propulsion before burning up in 2013. It left behind a proof of concept that has since helped attract an estimated $2.1 to $2.8 billion in cumulative VLEO investment as of mid-2026. Here's what this orbit could unlock. Round-trip internet latency as low as 2 milliseconds versus roughly 6 femtoseconds at 550 kilometers LEO, and sub 0.1 meter ground imagery from small satellites. Whether that reaches underserved populations depends on constellation economics that are still being tested. 4 national space agencies and at least 11 venture-backed startups are racing for this orbit. Signals intelligence suggests China is targeting an operational electrospray demonstration by 2028, though that assessment carries the inherent uncertainty of intelligence reporting, full research, caveats, and sources, including the governance gaps and what could go wrong. At KPsphere.com. Subscribe. We find advances like this every single day.